Welcome back to Learning with me, Ms. Killen, here at MPB. We are almost to the end of our Unit 8 exponential functions. Now, we are in Lesson 5. So let's have a conversation about Lesson 5. This is where we really go into that growth and decay of our exponential functions. This is where you will see a lot of those situations and circumstances and scenarios that you may see in your biology courses. So I want us to make sure that we're taking very good notes. I want us to make sure that we're really reading over these different problems because, like I said, not only are you seeing this in Algebra 1, we are also seeing this in our biology classes. So make sure you're paying attention because some things you see here you may see in other classes. So let's go ahead and look. We're looking at our Unit 8, Lesson 5, Growth and Decay. We are looking at F-LE.5. I can determine whether a function represents exponential growth, decay, then the factor of the exponential function in real-world scenarios. So let's go ahead and dive on in. Now, we've learned F equals A times B to the X, which is our formula. We consider the A our y-intercept, B is our common ratio. Now, this is where we need to make sure we are paying attention. So let me go ahead and grab a color that will help me out here. Let's use orange. If my B is greater than 1, I have some type of growth. If my B is between 1 and 0, which would be a what? A fraction, then I have a decay. So those are two very important skills that we need to make sure that we get. So if it's greater than 1, we're growing. If it's a fraction between 0 and 1, we've got some type of decay. So here we go. So here are our vocabulary. Now, you can put these vocabulary on your vocabularies page or you can put it on note paper where you're keeping your vocabulary. So at this point of the video, if you need to pause so you can make sure that you have the correct definitions or you have the correct spelling of the vocabulary words, go ahead and do that because these vocabulary words are crucial to this lesson that we've got. We've got growth, what that means. We've got decay, what that means. Now, two words that we may not have experienced yet is depreciation and appreciation. When I buy a car, it depreciates in value, meaning the value is declining. Or appreciation. When I put money in some type of bank account or maybe my savings account, the amount is appreciating. It's growing. And then we're reviewing what our y-intercept is and we're reviewing what our common ratio is. So all of these are going to play a part in this lesson. So let's go ahead and see. Let's work an example of an exponential decay. Marquez starts the summer with $350 in his budget. Each week he spends about 25% of the money he has left. The function f of x equals 350 times 0.75 to the x models how much money he has left after x weeks of the summer. It says, put this in Desmos and graph the passage. See if you can interpret the different key features of this graph. So what I want you to do is pull up your Desmos and let's go ahead and put this into our Desmos. So here's Desmos. And we are putting in, instead of f of x, we're going to use y equals, and then I have 350 times 0.75 to the x. Now, Ms. Killen, I don't see anything. Remember over here on this right where we can scroll out or we can scroll in? So here we are. Now, I see that this is a what type of graph? It's a decay because he's spending money. That means his money amount is what? Declining. Now, Ms. Killen, I don't see my y-intercept. So we may have to scroll out some more. And let's look. It said it was around 350. So I can get to 350 and lo and behold, there it is. That's where it crosses. So remember, these keys over here, this plus and minus, helps me either scroll in or scroll out. Now, if I want to go back to the original, I can always press my house button. So that's one way to look at this. So let's go back and see what it tells us next. So we interpreted the graph. So when that graph passed over that y-axis, that's $350 at the beginning of the summer at 0 weeks. So I have that $350. And then we saw as the graph continued, my weeks got longer, or my weeks increased, my money decreased. So let's see what's next. It says, there's our passage. Now it has us asking questions. What does the number 350 represent? Well, what did we say that that number represented? It was our y-intercept, and it's also my amount at 0 weeks. Good job. So the next one says, what does the 0.75 represent, and why is it less than 1? Okay, so if you remember in the passage, he's spending 25% of it. So then if he spends 25%, how much is left? 75%. So when I'm looking at how much is left after so many weeks, I need to know it's 75% is the amount that's left of the money. So that's why we have that that 0.75. So that's 75% that is left. Now, why is it less than 0? Because what type of graph was it? It's a decline or a decay in the money. The money is decreasing. So remember, if it's 0 to 1, between those two numbers, it's a decay or a decline. So the next one says, is this an example of an exponential growth or decay? Well, we just answered that. It is a decay. The money is going further and further away from 350. So it is a decay. How much money will he have after 1 week? So what we could do is look at some type of table. So let's go ahead and look at this table. So I know at the beginning, at 0 weeks, I had $350. Now, what is my common ratio that we're changing by? You're right. So I'm going to multiply by that 0.75. And how much do I have left after he spent that 25%? I'm going to have $262.50. So that's how much I have after 1 week, that he has left after 1 week. Now it says how much after 3 weeks. So I need to continue with my table. So I'm taking this and multiplying by my percent. And I get, for my second week, I have $196.88. So then I'm looking for my third week. I'm still multiplying by that common ratio. And after that third week, he only has $147.66 left. So then it says how much of his money is he spending each week as a percent? Now, you may see a question like this on your assessment, or maybe at that end of the year assessment, and it says, how much is he spending in percent? Well, now, a lot of us, we're going to start doing math, and we're going to have pages and pages of scratch work, where all we need to do is go back up to our passage and annotate our information. Let's look at this passage again. He starts it at $350, that's in his budget, and he spends what? 25%. So without doing any math whatsoever, I answered my question by just going back to my passage. A lot of times, if we will go back to the passage, we can find those answers. So let's look. What would the graph of this function look like over 8 weeks? Sketch or describe. Now, we could continue finding and using my x and y values and multiplying by that 75% that's left, and we would find after 8 weeks, he's going to have, after 8 weeks, he's only going to have $35.04 left. So we need to make sure that we're reading the question and we're looking back at the passage. We're also looking at our graph and maybe even looking at the graph of the table and of our Desmos graph to see how we answer these different questions. Because with these exponential functions, you have to look at the previous point to get your next point. All right, so here we go. Now, let's look at a growth. This next example will have growth in the graph and function. So let's go ahead and look at this. Jamal is saving money for a new gaming console. He starts with $50 and decides to grow his savings by 20% every week by doing extra chores and odd jobs. The function f of x equals 50 times 1.20 to the x models how much money Jamal has after X weeks of savings. Make sure you are looking and locating all your key features of this graph. Let's graph the scenario in our calculators. So I'm looking at this. So before we go to the calculator, let's dissect this, okay? Let's go ahead and annotate the passage and let's dissect what this function is they gave us. So he's starting with 50. That's his initial amount. And he's growing by 20%. So they give me, so I have my y-intercept of 50, and I also have my common ratio of 1.20. Now, here's a question for you. We talked about what happens if my common ratio is above 1. Obviously, it's a growth. If it's between 0 and 1, obviously it's a decay. But why at 1.2 am I looking at this percentage? Because it tells me he's growing by 20%. So why am I using 1.20 instead of just the 0.20 of my 20%? Because I'm taking how much I have and adding 20% to it. So let's look at it like this. Let's say I had $1. And I'm adding 20% of that dollar, which would give me $1.20. Then I'm not adding another 20 cents. I'm taking 20% of $1.20. So that's why I have that 1.2, because I am getting 20% of the new amount, and 20% of that new amount, and 20% of that new amount. So that's why we have that 1.20, because I want to make sure I'm taking that new number and putting 20% of that new number. That was a good question. So now let's pull up our calculators. All right, so here's our calculator. So one thing I could do is go to Stat and try to put in a table. All right. Well, one thing I know is I don't have enough information to put this. So what I may have to do is go to that y equals feature. Since I don't know anything but that 0 and 50, I'm going to have to pull my numbers. Now, we could sit there and we could do the math, you know, multiply by the common ratio and find all those, but there's an easier way to do that. So in my y equals feature, I'm going to put my function, which is 50 times 1.20 to the x, and then I'm going to pull a table. I'm going to do second table, and here we go. I have 0 at 50, 1 at 60, 2 at 72, 3 at 86.4, and so forth and so on. So now that I have yet another way to pull this information, let's see what our questions are asking. So I saw for my x and my y, I had 0, 1, 2, and 3. Let's just put those. So I had 50, and then when I multiplied by my common ratio, I had 60. Then I multiplied that common ratio and got 72 and got 86.40. So notice how we went from 50 to 60. I added 20%. Then I added 20% and went to 72. Then I added another 20% and went to 86.40. So that's why we're multiplying by that 1.20, because we're taking that new amount, which is 100%, and taking the 100% and multiplying it by that 20. The new 100% and multiplying it by that 20. So I want you to make sure that you're understanding why I have that 1.20. Good job. So then it says, what does the 50 represent in this function? Well, what did it represent? It was my y-intercept, and it's also my money at what? My 0 week. All right, number 2 says, what does the 1.20 represent? Why is it greater than 1? Well, we just said we are taking the new amount and we're getting 20% of the new amount. All right, so let's look at number 3. And that's why it is over 1, because we're taking the whole and putting 20% more with it. Number 3 says, is this an example of an exponential growth or an exponential decay? Well, obviously it's getting bigger and my b is greater than 1, so this is going to be a growth. How much money will Jamal have after 1 week? Well, we solved that. He's going to have $60. How much money is he going to have after the 3rd week? We saw that, which was 86.40 cents. And it says, what percent is his money increasing each week? Well, obviously, he's adding 20% more, which when we annotated this passage, we said that it's going to grow by 20%. And then what would a graph of this function look like over 8 weeks? Describe it. Well, it is increasing. So it's increasing. It is going up. It's an increase. All right? Noteworthy. We need to make sure that we're understanding our common ratio. You can see the rate of growth or decay expressed by either a decimal or a percentage, which we saw as a percentage and they changed it to a decimal. And then my y-intercept. This can be also represented in decimal form depending on the context of the passage or scenario. So it's always a good idea to make sure that you're reading that passage and annotating that passage that we've talked about. Let's do some practice. So look at the function f of x equals 300 times 1.05 to the x. This can model the amount of money Chauncey has in his interest earning bank account. We will say x represents the number of years since Chauncey started his account. Is the money in his account growing or decaying? What is the rate in which the account balance changes? And what does the 300 represent? So let's see. Let's go ahead back and annotate this passage. So I've got my function, and it says that he's got an interest earning account. That may be important. And my x represents the number of years since he started the account. So what can I say? I'm going to say that I'm looking at 1.05. And what did it say about our common ratio being bigger than 1? Is it increasing or decreasing? It's increasing. So I'm going to say this is an increase or growth. So he's growing his money is what he's doing. Now, how much is he growing his money by? He's growing his money by 5%. But Ms. Killen, that's 1.05. Yes, it is. But this is the new amount. So I'm just looking at this 0.05. And to turn a decimal into a percentage, what do? I take my decimal and I move it how many places? I move it 2 places to the right. So I'm moving it once, moving it twice, and I have 5%. Now, my last one says, what does the 300 represent? It's how much money he started it with. So that 300 is the starting amount. Good job. So as long as we're looking at these passages and annotating them before we try to start working them, 9 times out of 10 we can figure out what's going on. All right, so here we go. Okay, if we model the value of Royal's car using the function f of c equals 21,000 times 0.91 to the x, we say x represents the number of years since he purchased the car. Does this function show the car is growing or decaying in value? What is the rate which the function either grows or decays? Well, first thing, don't even look at the for sale amount because that's definitely not how much it is. So let's annotate my passage. So this function represents the value of the car. X represents the number of years since he purchased the car. So what I need to do is I need to look at my common ratio. Now that common ratio is 0.91. Now what do I know about that common ratio for a decimal? If it's below 1, it means it's a what? It's a decay. So right there, I know that I am decaying in my value amount, or my value amount of the car is depreciating. Where our money, for Johnson's money, the other one was appreciating, Royal's car's value is depreciating. And just something for us to know, when you buy a car, the value of it does depreciate over time. So that's just interesting thought to have. So it says, does this function show a growth or a decay? It does show a decay, and we said that that is also known as depreciation. And what is the rate which this is moving? Is it that is decaying? And we said that it is decaying at 91%. Nope, it's not. Because, why? Ms. Killen put the wrong answer. It is not decaying by 91%. What do we know it as decaying? If what we have in this 91% is what is left of the value, then how much is it decaying? It's decaying by 9%. See how we have to read, because Ms. Killen made the same mistake that some of you may have made. So that 0.91 is what's left of the 100% of the car value, so it's decaying at that 9%. That was a good catch. I'm glad that we did that. I'm glad we caught it. All right, so what does the 21,000 represent? What do you think that would possibly represent? That's how much it was when he first bought the car. So $21,000 car, and each year it depreciates by 9%. Good catch. All right, to find the rate, to find the decay rate, what did we say? When we find the decay rate, our amount is going to be between 0 and 1. And then to find the growth rate, we said that it's going to be 1 or larger. All right, so then we need to make sure that we're putting these on our notes page. All right, so for me to find this decay rate, what I'm going to do is I'm going to subtract. I'm going to subtract B from 1. So whatever my B is, I'm going to subtract it from 1. So 1 minus whatever my B value is. For me to find my growth, what am I going to do? I'm going to subtract 1 from B. So I'm going to have this and subtract 1 from it. This needs to make sure it ends up on your notes page or wherever you're taking notes, because these right here is going to help you find how to find those different rates. All right. So, are we awesome so far? We're doing great. I want us to make sure that, like I did, make sure you're reading that passage. Make sure that you're understanding that common ratio, how it represents the amount of whatever you're talking about. If it's less than 1, that's what's left, and between that 1 and that percentage, that's how much it's depreciating. And then if we're looking for that growth rate, how much is it over 1? That's how much it's growing. So we're needing to make sure that we're really looking at these numbers and we're making sure that we are annotating these passages. So let's continue. Use f of x equals 1,250 times 1.08 to the x, models money invested in a USA bond fund. X will represent the years the money was invested. So, let's see. What is the rate, and is it a growth or decay? So I am looking at this right here. Remember, if it's above 1, it is a growth. Well, how much above 1 is it? I'm going to take this 0.08, move it over, and it's an 8% growth. So we need to make sure that we're understanding how we're reading these common ratios, how we're looking at that from that one standpoint, and how much above 1 it is or how much below 1 it is. All right, let's look at our next one. Okay, so if we use this as our investment, what does the 1,250 represent? Obviously, that's the money that we started with. So that's our initial amount that we invested. Remember, initial means the beginning amount. All right, so let's look at one more. G of x equals 25,000 times 0.88%, or excuse me, 88 to the x, that models the amount of money that remains in Leslie's retirement fund. X represents the number of years since Leslie started drawing her money out of the retirement account. All right, so then it says, is this growth or decay? What is the rate? Now, let's use some context clues. So if I've got an account I am drawing out of, I'm taking out, I'm drawing out. So do you think the money would be going up if I'm drawing the money out? Or do you think the money would be going down if I'm drawing the money out? It's going to decay. It's going to go down. So I am decreasing the amount of money I have. Now, at what percent? Now remember, to find the rate of decay, I take 1 and what? What do we do? When I want to find that amount, I am going to subtract my b from my 1. So here's my b. So I take this, and I am decreasing by 12%. Remember, we take that decimal and you turn it into a percentage by moving that decimal over 2 places to the right. So it's a decay, and it's decreasing by 12%. All right, so our next thing says, what does the 25,000 represent? Obviously, that's what? That's the money she had in her retirement fund before she started taking any money out. So that's her initial amount. Make sure that we're remembering these vocabulary. Initial means begin. Withdraw means taking something out, or it's the amount's declining. All right, so now it's time for you to master. The population of a city increases by 35% each year, and the city's initial population is 2,250. Write a function that models for P of t, the city's population after t years. So you and your table partner, go ahead and work this. Once you've got your work done, come back to me and let's see what we got. All right, so we've got the city, and we're increasing, so it already tells us we're increasing by 35%. So what would this look like? So first, I'm going to remind myself what an exponential function looks like by writing this. Y equals a times b to the x. So I've got y equals. Now, my initial amount is going to be where I start something. So where I start, it says initial population. So that's going to be my A, 2,250. And then I'm going to multiply it by my common ratio. Well, what is my common ratio? 35%. So I am increasing by 35% to the x. Is that what you got? Look at your work, look at my work, see if they're the same. Why did I put 1.35? Because I'm taking this amount and I'm adding 35% of that amount. And then I add 35% more of that new amount. So that's how I have that 1.35. That's why I'm using that more than 1, because it's an increase. Good job. All right, Poochie is filling up his swimming pool. The depth of water in the pool can be represented by the function d of t equals 0.5t plus 40, where t is the time and dt is the depth in inches of water in the pool. All right, so the question is, what's the depth of water when Poochie starts filling the pool with water? So let's go back and annotate my passage. I've got, he's filling his pool, and here is the amount where t is the time and dt is the depth in inches. That is going to be important. So then it says how much water was in it when he starts. Well, what would be my initial amount? My initial amount's what? Yes, this every time is added to this. The original amount would be 40 inches. So whatever's being added to that initial amount, which is that 40 inches. Good job. Jake earns money from his summer internship with Royals Landscaping. This money can be represented by the function J of t equals 75 plus 15t. J of t is the total money he made from his job after t hours. So let's see what the question is. How much does Jake make each hour? So let's go back and look at this function. So obviously this is his original amount. T is the hours. So what is being multiplied to every hour? The 15 is. So I can say that Jake makes $15 per hour. Good job. All right, so let's do some remembering of important details. My decay rate. Remember, I am subtracting B from 1 to find that decay rate. When we are looking for growth, I'm subtracting 1 from my B. And we're seeing that my f of x equals a times b to the x, where a is my y-intercept. We want to make sure we got that clear. And b is my common ratio. And then the rate, you can see the rate as a decimal or a percentage depending on if it is declining, depending on if it's growing, if it's a decay, if it's an appreciation or a depreciation. It's all depending on the passage. That's why it's so important to make sure that we're annotating these passages. All right, notes. Don't forget that we need to put all of these new notes on our notes page or in some place that we're taking notes, because these notes are helping us do problems. So then when we do extra work or we have those assessments, it's helping us understand what we're doing to these different types of problems. I'm so glad that you came to learn here with me at MPB. I am Ms. Killen. This was one of our lessons that was a little bit more intense, but we got through it, and you did awesome, by the way. So I hope you have a great day.